My name is Bill Beck. Um, I've got a kind of a long story, which I'll try and keep short in my experience in the industry. Um, I'm currently with helping out Chirisa Investments. I'm working with them as Executive VP of Strategy, and that's on their acquisition and operating models. And prior to that, I was with Credit Suisse for 15 years, and I was recruited to go to Credit Suisse to build a data center strategy, which they really were in their infancy in terms of technology with scattered infrastructure. So I had to come in and identify what the data center strategy was. I had to syndicate it internally with all the stakeholders and their 5 CIOs, CTOs, et cetera. Build capacity profiling, pick the locations. Then I had to go out, design, build it, and operate. And so in the course of that, I also picked up the sustainability. I was in charge of sustainability and also all of their energy programs. And through that, I inherited innovation around that space. I got recruited to go there out of a company called Globix, which is one of the original dot-commers, I was in the industry for roughly 14 years before that in design, construction, operation of power plants, data centers. That's how I ended up with Globix. I built their headquarters and they recruited me heavily to come there. Two things, right? When the data centers were first being I guess rolled out as its own industry, so to speak. The financial industry was kind of driving the technology, but it was also around the resiliency levels, right, and the reliability, which was very expensive because at the cost of business downtime, right, which that was unquantifiable in their minds, it was build the most resilient, high availability, infrastructure you can, and then over time the whole idea was, and I had this argument internally too, is, wait a minute, technology, we're investing billions of dollars in technology. Technology at some point's got to lead the way on the resiliency piece. You can't rely on the infrastructure, forever, and it's expensive. To operate's expensive, and the same people that are complaining about the operational cost and the expense are the ones driving the resiliency level. And yeah, it was an educational process, right? And then also then moving to the colo model. At the time that I entered Credit Suisse in around '03, the digital realty was just starting. So there really wasn't a mature operating model that people could feel comfortable with around operating and co-locating outside of your space. Where I'd say it actually took off faster than the US was in Asia, where you built a data center within the confines of your office suite. So from an office environment perspective, most leases in Asia were 3 years. So you built all this infrastructure for 10 million, 20 million, whatever, and then you're going to re-up your lease in 3 years. Guess what? The landlord had a pretty good idea you weren't going anywhere. Yeah. And then it restricted you being able to move because then you had to build it again. So then the colo models were, because they were very small, you could have had 100 kW, 200 kW, 50 kW. You were more comfortable co-locating because it was your DR. It was your failover, and they never counted on ever having to use it because they built such a robust system in their primary and their production site. Yeah. But then as companies like Digital, like Equinix, they started really expanding. It was a better use of our funding, and they became the drivers behind the operational efficiencies, right? I mean, their whole context and their whole model, like when I was at Globix, was that's my core business model. That's not Credit Suisse's core business model. And so it allowed me more flexibility. Of course, it was winning the hearts and minds around there too. And even though it was my department, my group, it only made better sense from a business perspective because I was actually trying to push more into the innovation side, trying to help the businesses around the same people that are now our clients, right? We had the digital realties of the world as our clients, and we also had the CBREs and the operators and those people as our clients also. And so it was a kind of a mixing of the minds, so to speak, and what could be the best model going forward. Yeah, I don't think there's going to be a death of the enterprise data center. I think that there's certain production and data, integrity rules and regs and requirements that you'll be on site. They can't write a guarantee data protection in a colo environment. Their best bet is to try and maintain the majority of that data internally because it's the next best thing to them being accountable. Because if they, and I've had meetings with the Fed and the SEC, they're very binary in terms of the way they approach it. You're accountable and that's it. But then they start to dictate to you, well, you're not far enough away here and you're not far enough away there, but then they won't give you a distance on what is actually far enough away. And so the idea would be to balance, I think, the hybrid solution. And going forward, I think you're going to see that they're going to get a little smarter in what they considered to be their tier 4 critical solution. Years ago, it was something they didn't have to worry about. So they made everything tier 4. Meanwhile, only a subset, maybe 20%, 25% of their total kit and their software, needed to be in a high resiliency environment. And then the interconnect with all their databases, which is where the data integrity issue comes in, they've gotten a lot smarter and consolidated a lot more of their database and a lot more of their client data that way. So I think it'll shrink. I think their growth piece for a lot of the areas that they don't need to have that security with will go into a cloud environment until they hit a critical mass. And then they're going to realize it's going to cost too much money to do it, and then they'll look at it again. It's like the old mainframe distributed. It's kind of like what's happening with the data center. It's an extension of the nodes, right, on your technology. And so you're seeing hyperscalers, and now you're looking at the edge, right? So, the edge wasn't there. Everybody was moving to the cloud, going to the hyperscalers, and now with all the IoT that's out there, and 5G is an enabler, right? 5G in and of itself, to me, is not a profit-driven strategy. I mean, it may be for the Verizons and the T-Mobiles, but for someone who's, I wouldn't go, if I'm in Credit Suisse or I'm in some other, I wouldn't just say, oh, it's 5G, I'm going to pay X amount more for it. There has to be a need for it. So if your business is driven by the availability of the edge and IoT, that's a precursor to 5G. Yeah. So it'll take a little while to adopt. Plus, they have to get around standards around IEEE, et cetera, so they have common standards. Right now, you have, the network carriers calling themselves 5G, but they have their own design and standard around what they think to be 5G, and there's differences. First, whatever energy you use, you want to use to the most efficient manner you possibly can. So you design and build and operate to the most efficient standards, because the key to energy conservation is if you don't use it, you're saving it, right? So as opposed to just, and we had a 100% renewable, directive internally that we were going to, but we weren't professing it everywhere else because a lot of it was greenwashing that was out there. It was almost impossible to say that you were 100% renewable because you were buying offsets. So then you have to go and investigate the offsets, the quality of offsets. It's like buying gasoline at all these different stations of what leaded value is the right one, and like why is this offset better than this one? Either I'm getting a carbon credit or I'm not, right? So the idea was we were investing in thermal ice storage, in solar, in some of these energy. I wasn't a big proponent at the time of the battery storage piece because it just was very expensive, and it's not the greenest manufacturing process there is, but I think it's the answer to like microgrid, and it's the answer going forward to being able to optimize your power usage, right? So I think if you look at an urban environment or a suburban environment versus a rural environment, you're going to have to look at the balance of what you're going to bring in on renewables, right, versus what you can actually do within the facility to try and save energy. So the trick is going to be doing end-to-end, right? So you're going to look at the utility and buying wholesale energy, buying green where you know it's green. So you have to check exactly how that is, so they're not selling it 2, 3, 4 times, whatever, even by mistake. So you know where the green source is and how you're getting it, and they're not, and that it's only being, used once, to all the way down to the end user, and what you're doing with smart technology, what you're doing with IoT, and then that has to get integrated in software that's only now being developed to go end to end. But that's the key. The key is end to end, and so that people are just starting to pay attention. But that's in the next 5 years. That's the key, because it's going to tie into smart grids, it's going to tie into smart cities. It's going to, all that. If you don't have that software, that control piece in there to know which renewable is optimally suited at that time of day to be used because it's the most efficient, then you're kind of checking the boxes. Demand response, in its original definition, was to protect the utility from like brownouts, right? So when their demand was getting too high, they would call on a demand response, and so they would say, okay, anybody who can take their load from X to Y, that's already predefined, they will get money from the utility, to offset their efforts in doing so, right? So it's really in the highest, most densely populated in usage areas is where demand response was really of most value. Well, you have to start picking and choosing optimally what renewable or what system that you need to deploy, right? So like, I was just talking about, the solar guys and the wind people, they're on a separate, you know, um, P&L, so to speak, in terms of the way they go out and they deploy their projects. They want to maximize what it is they can do to write a PPA to somebody relative to the investment that they make, right? So but now if you're a hyperscaler or you're a campus builder, then you want to, pick and look at what your ultimate load should be, and then be able to scale each of those components of your microgrid so that you're not overbuilding, right? And you're optimizing what you're using at what time of day. So even from a utility perspective, almost every utility operates with less power costs at night than during the day. I mean, probably the only, like here, is probably one of the few that don't, because it's hydro. Right, right. But in other than this being one of the anomalies, every other location has certain optimal times that you want to be able to run a certain part of that infrastructure. And that's where the software comes in. That's where it optimizes. First, I don't think that this one industry is going to solve. I think they can contribute to the technology around it, but I've looked at a lot of research relative to what the scientists are doing, from NASA to some of the universities, some of the high research places. It's amazing some of the things that they've come up with. Now, first, is climate change happening? Yeah, climate change is happening. You can argue about the drivers behind it and who's responsible, whatever. It doesn't really matter. The fact is it's happening, and so what we need to do is minimize it, right? And if you look at the short-term fixes like carbon sequestration, it's like that's not permanent. You have to eliminate the need, right, and optimize the demand so that, I mean, this has been going back, I think calculating about 15, 20 years ago. If you could control the time of usage that you're using energy in the US, you could get rid of 40% to 45% of the actual generating capacity, because it's all peak. At a certain level of that peak, and that's where the coal and the oil and all those things are playing out. If you could, and this is where microgrid and smart grid comes into play. It's just sad that it hasn't been deployed much earlier, but I think the software is only starting to catch up. The digital infrastructure age is only hitting the power industry, which is kind of sad because it's been a driver behind our industry forever. Yeah. So it's almost like, well, everybody's just hunting for cheap power as opposed to trying to optimize the power that they're actually in whatever. With the edge being in play, you're going to need data centers, even in very high cost power usage locations, so you have to optimize. So the answer could be renewable. Could be renewable with battery and then tying into the grid. The loads in a data center are ideal for utilities. They don't fluctuate, right? They're pretty consistent. I mean, you have small fluctuations, so they're an ideal candidate for utilities. It actually helps their grid stabilization. Demand response based on your infrastructure, right? And having alternatives on your renewable side to help supplement. If you put only a certain percentage of, let's say you did your fuel cells because you have a very good gas supply and fuel cells, and I know we talked about Greenpeace and they talked about not using gas, but fuel cells don't combust the gas in the same way that if you had a gas generator would do, a combustion generator. That you're pushing some emissions, less than oil, less than coal, but you're still contributing emissions. Fuel cells do it, they do it more on a chemical process, so there's a lot less contribution. But when you look at, it is definitely going to be a step on the way. Yeah. So you can't dismiss it right now because it's a very good technology relative to the alternatives that are out there that are not. So every little bit it's going to help, and I think the more you optimize the type of energy that you're using, the better handle we're going to get on exactly what we're doing environmentally on climate change. And just building something because you want to call it green and you build a 50 megawatt solar plant doesn't mean it's optimized. If you ever watch the way the solar operates in the course of a day when a simple cloud cover comes over, oh my gosh, it's got these crazy dips, and that's where they have to use capacitor banks and things like that. And utilities only look at things on a second interval. They don't look at things on a milli or micro. We used to help with the utilities in terms of measuring their power quality because they couldn't see the same things we could. They thought they were fine. Meanwhile, they'd cause an anomaly that would chip off our chiller plant and not even know it. So they have to get as sophisticated as the end user does, and that's again one of the ways microgrid comes in because they can leverage that technology.